Hello everyone. In this video, we will be discussing two numericals in the worm gear. So already in the previous video, we have discussed one worm gear numerical, that is the complete designing of the worm gear. But in this video, we are not discussing like the complete design procedure. Apart from that, what are the other possibilities of asking worm gear problem that we will be discussing in this video. It is basically very simple problem. Before moving to these two problems, so already in the previous video we couldn't able to complete up like the problem where we have ended up with AGMA the power value. So afterwards in the same problem where we will be continuing the efficiency value. So efficiency value we are taking down from the equation number 23.604H, where this is the efficiency formula. So here what will be the unknown means already the lead value and normal angle we know that. So here the only unknown will be the rubbing velocity, that we will be taking from the data handbook equation number 23.571a. So the rubbing velocity formula is pi d1 n1 divided by 60,000 into cos of lead angle. After substituting the known value, that is d1 n1, the lead angle value, I am getting the rubbing velocity value as 9.023 meter per second. And with the help of this quotient of friction formula, where the V value I am getting in the range in between 2.75 to 20. So the formula would be 23.570C. So that is 0.025 plus Vt divided by 305. So I'll be substituting the exact Vt, that is the rubbing velocity water I got, I'll be substituting, and I'll be finding out the quotient of friction, and in turn I'll be finding out what is the efficiency. So the efficiency value I'm getting it as 85.22. And even we have other formula also to find out the efficiency, that is 23.597K. The formula is tan gamma divided by tan of gamma plus that density. So where density is nothing but the friction angle and the gamma is nothing but the lead angle. So here I do not know what is the friction angle value, that can be find out by the tan inverse of mu value. So tan inverse of mu, since I know the mu value, I can able to find out what is the friction angle, that is 3.1243 degree. So by substituting in this formula, I am getting again the efficiency is equal to 86 degree. Here you can able to see both the values are almost closer. But in examination, it is not compulsory that you need to show both the things. If you're okay with this thing, then you can go with the second formula. Or like anyway, for the to find out the second one, even the mu formula is also required. Or if you're comfortable with the first one, that is also fine. Then next step would be for the fourth step, the heat balance, where the formula is 23.603 from the 23rd chapter design data handbook, and the formula is Hg is equal to mu into Fn into rubbing velocity divided by 1000. So the heat generated will be getting in terms of the kilowatts. So where Fn is nothing but the normal force, the formula is 2.5, that is 23.546. So the formula will be 2mt2 divided by d2 cos gamma into cos alpha. So even we can write that as ft2 divided by cos gamma into cos alpha. So I am getting the Fn value as 82.5 Newton, and in turn the heat generated value I am getting as 4.08 kilowatts. And the last last step will be the heat dissipated, where the Hd is equal to HCRA Tg minus Ta by 1000. So where Tg is nothing but temperature of the gear and T is nothing but ambient temperature, that we can assume based on the the material. So it is I'm assuming, and the values should be substituted only in Kelvin. So 338 Kelvin and 298 Kelvin for Tg and Ta, and A is nothing but radiating area of housing, the value which is given in the data handbook itself. So that is 14.4 into center distance power 1.7. So after substituting all these value, I am getting the heat dissipated as 11.95 kilowatt. So this part is a continuation of the previous video, since I didn't get time to explain all these things. So I have explained in video 10. After watching video 9, please do watch video 10 to complete the previous problem. Now moving to the actual problem what we are planning to discuss in this video, that is two simple problems. So we shall discuss, and both the problems I have taken from the VTU prescribed textbook Design of Machine Elements authored by VH Bandari. So the given question is the following data refers to a worm and worm gear drive. Center distance 200 mm, pitch circle diameter of the worm 80 mm, number of start 4, axial module 8 mm, transmission ratio 20. The worm gear is made of Pasper bronze with the allowable bendings as 55 megapascal. The worm is made of hardened and ground steel, and the tooth form is 20 degree full depth involute. So we need to find out number of teeth on the worm gear, lead angle, phase width of the worm gear to transmit 15 kilowatt of power at 1750 rpm of the worm based on the beam strength of the worm gear. So let me quickly write down the given data. So center distance 200 mm, D1 80, Z1 4, M8, I20, allowable stress 55, 20-degree full depth involute teeth, and power 15 kilowatts, and speed 1750 rpm. So this is not a design. So they very clearly mentioned what we supposed to find out. So we know how all these things, since already we have done the design. Very quickly we can find out. So we need to find out number of teeth on the worm gear by using the velocity ratio formula, that is I is equal to N1 by N2 which is equal to Z2 by Z1. So let me go with these things only, since I know N1 value and even I know I value. From this Z2 value I can able to find out. Even Z1 value is also known. So let me find out very quickly, like Z2 value, that is I into Z1. So 80 is the Z2 value, that is number of teeth on the worm gear. And lead angle, that is tan inverse of m Z1 by D1, that is the formula we know. M value is known, Z1 value is known, and D value is known. So while substituting in this formula, I am getting lead angle is 21.8 degree. Next one is phase width of the worm gear. So the transmitted load FT2 is equal to 9550 into 1000 into power divided by N2 R2, since it is from the worm gear. And the N2 value I can find out from the transmission that is velocity ratio formula. So I am getting N2 as 87.5. By substituting in that, I can able to find out what is N1, and in turn I need to find out even D2 with the help of center distance formula, that is A is equal to D1 plus D2 by 2. Since D1 is known, A is known, so D2 I am getting as 320, and R2 value is D2 by 2, because this formula demands R2, N2 R2 is there, no. So D2 by 2 will be the R2, so 320 divided by 2, it is 160. While substituting all the values, that is what is that, capital N value, that is 15 kilowatts, small n2 value and r2 value, we can able to find out the f2 to ft2 value as 10232.143 Newton. And from Lewis equation, permissible transmitted load, where the formula is allowable stress into phase width into y into m into cv, that is normal module into cv, where y2 value as usual we will be taking from the data handbook, and y value I am getting as 0.448. So from this even normal module and velocity I will be finding out. Finally, based on the velocity I am getting the velocity factor as cv, and the phase width value I am getting as 70 mm. And we shall move to the next problem. Very simple problem. This also have taken from same author V.H. Bhandari, and book is Design of Machine Elements. So a 2 teeth right hand worm transmit 2 kilowatt at 1500 rpm to a 36 teeth wheel. The module of the wheel is 5 mm and the pitch diameter of the worm is 60 mm. The normal pressure angle is 14.5 degree. The coefficient of friction is found to be 0.06. So find center distance, lead and lead angle, forces and efficiency. Quickly we can find it out, because we know D1 is 3 pi m, module is given. So D1 value is 48 mm, center distance formula is D1 plus D2 by 2. D1 and D2 is known, so center distance value is 54. Lead, it is P into Z1, P is pi m. So here also all the data are known. So lead value is 31.416. Lead angle tan inverse of PZ by pi D1. So all the data is again known here. So lead angle value I am getting 11.768 degrees. See, all the first 4 terms are very easy. We can easily find it out. Then moving to the second one, axial force and radial force. Both the formulas is available in the design data handbook. Here also all the values are known. That is lead angle, phase width, ft1, everything is known here. By substituting in this, I am getting the axial force on the worm as 1937.44 Newton, and radial force on the worm I am getting as 518.52 Newton. So the force components acting on the worm wheel, where I will be finalizing as this one, and moving to the last step, that is efficiency. Since the worm is the driver here, take down the efficiency formula from design data handbook as 23.604H, and even if you are okay with me, you can go with 23.597A also, because just now in the previous problem we discussed, that is a design procedure problem, we discussed these two formulas. So from the first formula, that is from 23.604H, I am getting the efficiency value 76.075, and from the second formula I am getting the efficiency as 76.67, almost similar we can able to see here, where in the second formula we need the friction angle value, that can be found out with the help of a coefficient of friction, and both the values we can compare it, or if you are okay with any one formula, that is also fine for the examination. So with this I will be winding up this video. Thank you.